consists of two things, the central nervous system and the peripheral nervous system.
What's the difference?
The central nervous system consists of the brain and the spinal column,
Eric, just sit there.
whereas
Just
the
sit there.
peripheral
Yeah.
nervous system is everything else.
So I tuned into a back.
Right?
Wait, so
No,
Oh.
no so for you.
you should sit there.
All right. Now the brain is a mass of about 100 billion neurons that are located, if you didn't know, inside of your skull.
Really?
Okay? Alright, now, the neurons and spinal nerves are surrounded by a substance called cerebrospinal fluid. Alright, now the cerebrospinal fluid helps to nourish the brain and spinal column, and it also helps to protect it. So you could do things like this. Ah! And you're still alive.
Really?
How does it nourish it then?
So, now if you didn't have cerebrospinal fluid and you tried to do something like that, your brain would smash against the sides of your skull and destroy the neurons, and you would die.
You know what that sounds like?
What?
It sounds like that hurts.
Actually, yes, you can have problems with it. Yeah.
Oh no. Oh no.
There are diseases with problems like that.
No.
I will never get it. All right, somebody said, how does it nourish it?
Yes.
Does dying hurt? Shocker.
Because
No, it probably doesn't.
nutrients diffuse from your blood into the cerebrospinal fluid and then to the neurons.
Oh.
Okay?
Okay.
The blood does not go there. Now, all right. Now, if you notice, we're looking here at the cerebrum here. This portion that we're looking at the brain from above, and you notice all of these bends and folds in the surface. What do the bends and folds do? Why is it important that we have lots of bends and folds in our brain? What does it do? What if it was completely smooth? What would the difference be?
Less space.
There would be less area, less surface area. All right? Yes, because it turns out that the cell bodies of the neurons, all right, so that means where all of the work is beginning. So the cell bodies of the neurons are out on the surface of the brain. Okay? And then the axons go into the brain, right? So all of this surface area is coated with the cell bodies of your neurons. Okay? So that's why brain injuries like concussions are dangerous. Because when you hit your head and damage the neurons, the ones at the surface, that's where all the action is happening. So if you destroy them, then it's too bad. Right? Because all the stuff that's on the inside of the brain is just all of the axons, right? Heading out to do their work or coming in from doing work. Yes?
Then why do they say you need 3 concussions to die or something like that?
Oh, well, you want to find out how many concussions you need to die?
Yeah.
I've heard it only takes 1.
Oh. Okay.
Yes, one.
Now, alright, so now this cerebrum that we're talking about, it's the largest part of our Homo sapiens sapiens brain. Alright? Now it is responsible for your thought, alright, your language, your senses, and your memories. Alright? Your eyesight's back here, and your voluntary movement. Okay? So that is any movements that you do that you think about doing. Or in some cases that they don't really think about doing before they do them. Alright. Now, inside your brain, we were to slice it in half. We would have the thalamus, so that's the red structure there. That is a relay center, so it's going to take, as the information comes up into the brain. It's going to be relayed to hopefully the proper area of the brain. Right? And then just below the thalamus is the hypothalamus. Now this is that control center for the brain that we talked about yesterday. This is responsible for your recognition. So this is how you remember people in your lives, all right? And such, and faces, facial recognition. Hunger, thirst, body temperature, and fatigue, which is your sleep-wake cycles. Right? That's all controlled in the hypothalamus. Right. Now, underneath the brain, you have this little, it looks like a ball of spaghetti-like structure here. All right. This is the cerebellum. Right. Now, the cerebellum is responsible for your muscle coordination, your balance, and posture. Now, the difference between the cerebrum and cerebellum is, in the cerebrum, you can continue to make new connections and learn new things your whole life, right? So it's rather malleable, right, for figuring how to do things, how to know about things, all that kind of stuff. But the cerebellum, it develops up until around the age of 7. Right? And then it doesn't do anything anymore other than retain the information that you learned. Now, the information that you're learning in there are things like, now muscle coordination might seem general to you, but you don't really think about all of the muscles that you use in your life. And some of the important ones for humans is the muscles of the tongue and the jaw and the larynx in order to form language. Right? So, if you learn a language prior to the age of 7 or 8, you are usually fluent and it is so effortless for you. But afterwards, you can no longer figure out how to move the muscles of your mouth to form those sounds in your cerebellum, which is all automatic. That's what's nice about the cerebellum. Everything you learn in this part becomes automatic. No conscious thought about doing it. Instead, future language, you've got to rely on your cerebrum. So it takes a moment to figure things out. Right? So, when it comes to posture, I love to use myself as a good example of that. If you've observed me, you will definitely know, and I will agree with you, I have terrible posture. I slouch all the time, all right? It is just how I carry myself. It is because no one ever corrected my posture when I was a little kid growing up, right? So no one really ever talked about my posture until I think I was in my teens, like 16 or 17, when I started getting back problems from it, all right? Now, I can sit up straight, right? If somebody says sit up straight, I can do it. But I have to use my cerebrum to do it. Naturally, I will always gravitate to be in a slouch position. Right? So it's the same thing with your balance, right, and walking, right? If you learned how to walk before you were 7, right, you're able to walk and you don't even have to think about it. Right? There's all these little muscles making small adjustments for weight balance. If you turn and do all these kind of things, right? When you're a little kid, you're stumbling and falling, especially little babies. When you watch them when they first talk about toddlers, is they're crashing into things and they lose their balance and fall over. That's the cerebellum figuring it out. You know, the cerebellum will be like, oh, I guess I don't do that next time, then I won't fall over, right? And so you become an expert at it, right? As long as it's before 7. Anything you learn after 7, it's all cerebral. And you've got to think about it before you do it, even if it's just a momentary thought. Yes?
Wait, so if you learn like 5 languages before 7, will you be like super fluent?
Yes. Yes?
What if you learn how to do a handstand before you're 7? Then will it come like
You-
naturally?
Yes, it'll be really easy for you.
Oh,
Yeah.
okay.
Yeah. Yes. When you were little, it would be much better at it than when you try to do it later. Because later in life, what's going to happen is it's not going to be a natural thing for your brain to do. You won't have to just do it. All right? You're going to have to think about it. Now, you can do gymnastics. You can learn foreign languages and all these things later, but you are entirely reliant on your cerebrum to do that. Okay? It's no longer going to be effortless. All right. So that's our cerebellum. All right, brainstem. So the brainstem consists of the pons and the medulla. All right. Now this is it's usually called the primitive brain. All right. This is where your most basic bodily functions are controlled. All right. This is your life or death things. Breathing, and this is things like not breathing like, oh, I'm going to hold my breath. Right? Because that I'm using this. Now, this is breathing when I'm not even thinking about breathing. I mean, how often in a day do you really think about breathing?
Like one.
Every day.
Yeah, never. Right? You don't do it that often. Okay? Now, swallowing, same thing. You swallow all the time and don't think about it. There are times when you swallow and you think about it. Right? But at night, when you're sleeping, you're constantly swallowing. You don't even know it. Right? And can you imagine if we had to think about our heartbeat all the time? We would never think about anything else. Right? So these are all things that are important for keeping us alive. Right? So this is why if there's an injury here, right, it's usually fatal. Because it can't recover from that.
So if you snap your neck, are you dead?
Generally, yes. Yeah. Breaking neck is usually really bad. And that's because neck here. Right? So if you break that part, all of this communication going on down there, gone. Right? Now, if you get low enough, all right, you might still be able to breathe. Right? If it comes out, I think it's this one right there. All right, you'll still be able to breathe. You'll still be able to do and to see and do all kinds of other things. But and your heart will still beat, but you won't be able to walk, move your arms. Right?
So can doctors fix that?
We're still trying to work on that, but as of right now, generally, no.
Oh, so this will be paralyzed and impaired forever.
Correct. So it's bad. So take care of yourselves. Yes. All right. So the spinal cord is mostly the axons coming out of the brain or going towards the brain from your neurons. All right. Now there are interneurons inside of the vertebral column. All right, and those interneurons are primarily responsible for your reflexes. All right, now how a reflex works is essentially you're going to step on something sharp, and you don't even think about it. Your foot's going to automatically lift up. Now, what happens is there's a signal that comes up from that sharp thing, goes into your spinal column. The interneuron relays right back down, lift up. All right, that's bad. Now, at the same time, the signal keeps going up to your brain to tell you, hey, you just stepped on something sharp. Right? Now, reflexes are good because if you didn't have it, you'd step on that sharp thing, and then it would come to your brain, and you'd be like, oh, that's pretty sharp. I guess I should lift my foot up. Or maybe I shouldn't. I don't know. Right? So it's a good thing to have that automatic thing to stay away from. So we catch some of those reflexes. We actually have more reflexes when we're babies, and they kind of go away as we get older. All right? Because we just don't need them. All right. So the peripheral nervous system consists of sensory nerves and motor nerves. Now these are the neurons essentially that come out of the brain and spinal column. So you're going to have your sensory nerves. These are responsible for carrying messages to the brain about your external and internal environment. Right? So it's letting your brain know what's going on. So this is pain, pressure, temperature, pH, taste, sight, those kind of things. All right? They're all going to the brain. Now the motor nerves are going to carry messages from the brain out to the body to respond to these various internal and external environmental conditions. Right? Now, you guys did this all on your own, so I'm not gonna go through that. So you got your, in the motor division, we've got two branches. We've got the somatic, having to do soma, consciousness, right? Has to do with skeletal muscle. So in the somatic system, it's all the stuff that you can control on your own, right? You wiggle your ears, you're doing that with your somatic system, that kind of stuff. Okay. Autonomic, though, is further branched into the sympathetic and parasympathetic divisions. Now, the autonomic division of the motor system is unconsciously controlled. These guys are going to happen whether you want them to or not. And in the modern era, where we don't get chased by bears very often, generally when these guys kick in, we wish they didn't. Right?
Like,
What?
What?
like,
Stress, yes. All right. So the sympathetic division is our fight or flight response. That's what it gets the name of. Now, this actually kicks in when you do exercise. So when you're out there running that mile and oh my God, I can't do this anymore. I just can't go. All right. Trust me, your sympathetic division is hardwired to think, oh my God, they're running from a bear or saber-toothed cat. Ah!
What if you just don't care?
Well, it doesn't matter if you don't care. Your sympathetic division is like, you're running, so the only reason that you should be running is because there's a saber-toothed cat chasing you. So we need to kick in all this stuff to protect you. Oh my God!
But how do you just decide to stop running?
There's also moments of excitement it will kick in, like, oh, she said hi. And then you just stand there, and then she walks away from you, and then you're like, oh my God, I'm so stupid. Right? That was thanks to your sympathetic division, makes you stupid.
I don't feel sympathetic for that.
In emergencies, all right? In an actual emergency, it's pretty good, all right? It's going to do some good things for you, all right? Keep you away from that actual saber-toothed cat. I mean, we are in Fremont after all. They used to roam here, just saying. Yeah. And then embarrassment, ha! All right? When you have to get up in front of class and give that speech, and you stand up there, and all of a sudden, you're standing like this, but you think everyone sees this. All right? Now, so what's going on when the sympathetic division kicks in? All right? So your brain is getting ready for action. Your brain is like, it's an emergency. Oh my God, giving a speech is the same thing as getting mauled by a lion. You're gonna die. Alright? And so, adrenaline gets released. So those little adrenal glands that sit on top of your kidneys, the little hats on the kidneys, they're gonna release adrenaline into your bloodstream, and the blood pressure is gonna go up because your blood vessels are gonna constrict down. Right? Your liver is gonna release glucose, right? In order to get sugar out there so that when you gotta run from that lion, right, you've got enough glucose to keep you going. Okay? Now, your pupils are going to dilate, right? The pupils dilate. This is important, right? In that moment of need, oh my God, you need the maximum amount of light and the maximum amount of information to get into your eyes. So if your pupils dilate, you can see just a little bit more, right? And you can get just a little bit more information, but that could be the difference between life or death, right? Now, your mouth goes dry. Oh, you get cotton mouth when you're up there giving that speech. All of a sudden,
Yeah.
what's going on? Well, it turns out when you're getting chased by that saber-toothed cat, you do not need to worry about making saliva. So the glands shut down to save energy. Any little bit of energy to save. Because you know what? Wet or dry mouth, if this gets you, it don't matter no more. Right? So let's save even a tiny amount of energy as making saliva is going to help you get away. Fine. All right? Let's get away. All right. tense. Your muscles are going to tense up and everything because you're ready to go. You got to go, which direction am I going? All right? Your heart's going to pump. You know, you're up there giving that speech, and you boom, 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 boom. You hear the blood coursing. All right? You're really ready to go there. Right? You get all sweaty. Right? Your palms sweaty. Everything's sweaty. And this is because your body is ready to cool you down because you're going to be running, right, for your life, right? Fast and shallow breathing, right? Because you need to get that oxygen to all your muscles, right? Now, other things that happen is your digestion actually slows down or stops altogether because digesting food takes a lot of energy, actually. And so you don't want to waste any of that energy because, yet again, that food in your stomach or intestines is not important if you're just going to get eaten, right? We can digest that food after you're away from the saber-toothed cat, okay? But when he's after you, it doesn't matter. The only thing that matters is you surviving, okay? So we got to do that. So digestion slows or ceases. Sphincters close. All right, many of you have siblings, so I'm sure you've experienced this at some point in your life where you're going to the bathroom and bam, hi, God, get out of here, oh my God. If we could get them out finally, and then you're back alone in the bathroom, and then, you gotta wait. You can't just keep going, right? Right? If you're going midstream, the stream cuts off, right? And then you gotta wait till you settle down, and then you can start peeing again, right? So that's what's happening there. Now, often students ask about, but don't some people wet their pants or poop their pants when they're scared? This is true. It turns out that a certain portion of the population, and you really don't know who it is until it happens, right? And what it is what happens is when that sphincter closes, sometimes there's a spasm, right? And sometimes it spasms and stops open, right? And so then the ureter just dumps out all of the continents here. And so your urethra is going to let out all of the contents of the bladder, and oops, you wet your pants, right? So then you know, oh, you're a pants wetter. How about that? Right. So that happens. Now this last thing here, cortisol being released to depress the immune system, this is something that is good if you have an occasional emergency, right, like this. Because the immune system also uses energy to fight off infections and things. But again, we don't need to be fighting off an infection when we might just be somebody's dinner, right? So we could stop that and use that energy to get away. Right? Now, the problem with this occurs in our society, especially in the United States. Right? We live in a very high stress environment here. All right? We are constantly stressed in school. We're constantly stressed in work. Right? Now, what's happening to us as a society, and we're seeing more and more of this, is that this cortisol is being released throughout our bodies all the time. And so it's damaging the way